Hello everyone, welcome back to the fifth video in my Vex CADing tutorial. In this video, I'll be showing you some advanced assembly concepts. At this point in time, you should all be familiar with how to use mates to create a CAD assembly. If you aren't, please feel free to go back and watch the previous video. Now, in this session, I'll be showing you what sub-assemblies are and how to use them, as well as some additional mating concepts such as linear patterns, circular patterns, replicate, and assembly mirrors. First off, what even is a subassembly? A subassembly is a smaller pre-built module of components that gets integrated into a larger final assembly. In other words, it's a smaller assembly with a one piece that you will use multiple times in the larger final assembly and keeps the organization much better. These subassemblies can be very useful because they improve the efficiency and organization of the document. With the subassembly, you will no longer have to rebuild the same part over and over again, increasing your speed and efficiency. Also, because all the parts in a subassembly are grouped together in the final assembly, the features and parts list in the final assembly will be a lot more clearer to read and a lot more organized. An example of a subassembly would be this wheel assembly you should have created previously. Although it isn't the full robot that we're trying to create, you can use it multiple times in the final assembly to put together the final robot. Now, I will show you how to use a subassembly. To use a subassembly, you first need to create your final assembly, as so. I'm going to rename this assembly Final Assembly. Now, to use the subassembly, you need to insert in the subassembly using the Insert tool at the top left. Next, you will click on Assemblies, and you'll click the subassembly you want to use. To insert assembly multiple times, you can simply click on the assembly subassembly multiple times as well, like so. And once you're done, you can click Check. Now you can see that you have multiple wheel subassemblies, both of which are mated together properly. Also, if you look at the features and parts list, you can see that it's organized into groups. However, let's say you already started creating assembly in your final assembly, but then you realize that a subassembly would work much better for this purpose. Well, what can you do? If you want to move a couple parts into a subassembly, you can simply click on the parts, right click, and click Move to New Subassembly. One thing you should note that is unless you click the mates that are attached to the subassembly, this will happen and they will no longer be mated. Moreover, once you create a subassembly, if you delete the subassembly, you will see that parts in the assembly that's created related to this will also vanish. However, let's say you do not want to create a subassembly, but you want to have the same effects of a subassembly. What can you do? To do this, you can simply group your parts. To group multiple parts, you can simply click on all the parts and click on the group feature on the toolbar and click check. Now, you can see that the two objects will move together. Moving on, I will now be showing you some more advanced assembly concepts. The first one I'll be covering is linear patterns. Let's say we want to add a screw into these two holes, then skip 3 holes, add another 2 in these 2 holes, then skip another 3, and then add screws in these 2 holes, and so on.
Creating every mate individually would be very complicated. So instead of doing so, you can use something called a linear pattern. A linear pattern generates a part or an instance in a single line multiple times with all mates kept. So now let me show you how to use linear pattern. First, you would want to mate this to the C channel. As so. Now, you will find the linear pattern tool. Next, you click on the instance you want to use and you choose the direction. To choose the direction, you can simply click on a line that is parallel to the direction you want to go. Next, you choose the distance between the two instances. In the C channel, one hole is half an inch apart. So if we want the two to be right next to each other, we'd put 0.5 inches. And now we have two. Now if we want to do the same pattern for the next view, we can simply create another linear pattern. Now click on both instances, choose the direction once again, and change the distance so that is now 2.5 inches. Let's say we want another pair of screws, but this time they're 5 holes apart. Once again, we can use the linear pattern tool. Click on these two, choose the direction, and add in the distance. There. However, sometimes making this many linear patterns can be very complicated, so there's another way to do so. Let's move back to when there was just two. Now, instead of making multiple linear patterns, you can actually go back to this linear pattern and choose a second direction. What a second direction does is that it uses the linear pattern you already have and now creates another linear pattern starting off with these two. So I can once again choose direction and choose the distance. Now it's 3 holes apart. I can once again do this with the third direction. And you can see that it starts off using the second direction and once again creates it. And this linear pattern caps at the third direction. Another feature of the linear pattern is the centered feature. If I click on center, the instances will now come on both sides in an equal distance. Additionally, it will add in another instance. Moving on, I'll now cover an assembly circular pattern. The assembly circular pattern is very similar to the linear pattern, as in you use a mate and the circular pattern will now create multiple instances with that mate. Except, unlike a linear pattern, the circular pattern does it around a certain point and uses degrees instead of inches or whatever distance you're using. So now to use the assembly circular pattern, I'll first mate this to the gear. as so. Next, I'll find the assembly circular pattern. I will now click on the instance. Now I will choose the axis of pattern, and you'll see that it begins to rotate around it. Now I'll choose the angle I want. To fill in these 4 holes, I will need to use a 90 degrees. And now I can also create 4 of these, and with 360 degrees, it now covers every single hole. Moving on, I'll now be covering replicate. Let's say we want to add the screw into all 8 holes of the license plate. Here, you could use assembly linear pattern, but another way to do it is to use the replicate tool. So first, like the linear pattern and circular pattern, you will need to mate the screw to the plate, as so. Next, you will search up replicate. Now, you can choose the instance, and the mate will automatically pop up. Now, there are multiple ways: match edge on face, match edges on plane, and match individual edges. In these tools, match edge on plane finds all similar mates in that same plane. Match edges on face allows you to choose individual faces for these mates to be replicated. Finally, match individual edges allows you to choose an edge specifically where you want this replicate to be used. For this case, I'll be using match individual edges. Now I will find edges where I want the screw to be. And now we're done. Match Using replicate is better than linear patterns and circular patterns in some cases because it allows you to match individual edges and faces in various different shapes, even if it's not an exact circle or a line. Moving on, I'll be now showing you about the assembly mirror. Let's say I have an assembly like this. Let's say I have an assembly like this with a license plate and a C channel. What if I wanted to mirror this so that there was another one mirrored like about 15 inches away or 3 inches away? What can I do about this? One thing I could do is use the assembly mirror. First, to use the assembly mirror, you need to create a plane where the assembly will be mirrored across. However, in assemblies, you can't create planes that you might see in a part studio. So rather, you would create a mate connector, as so. Now, you will you will move the mate aligner such that it is half the distance away from where you want the reflected part to be from the original. In this case, that would be 1.5 inches. Now, you will find the assembly mirror tool. Click on the instances to mirror. Choose a plane, which would be the mate connector. Now after choosing the plane, you will see that the assembly has been mirrored, with both being 3 inches apart. And that's it for advanced assembly concepts. Congratulations for making this far! And now it's your turn. Practice using the concepts you have learned so far to create a C-channel with bearings, a drive sandwich, and attach the cross brace. Note that I will be showing you how to create this in a few seconds, and an example of how the model should turn out will be linked in the description below.
you for watching. If you have any questions, feel free to comment it down below.